So in this video discusses about how we can be able to evaluate the empirical formula as well as the actually molecular formula. So you should have to understand that there are two types of the chemical formulas of a compound. We have what you call empirical formula as well as the molecular formula. So empirical formula is said to be the formula that shows the simplest whole number ratio of elements. And while the molecular formula is said to be the formula that shows the actual whole number ratio multiple of, I should say, this is the formula that shows the actual whole number ratio of the elements in a given actually a compound. Let's say we have a compound, let's say given as N2, let's say O4. Now, as you can see on the compound, a compound consists with two atoms, rather two elements, that is nitrogen as well as the oxygen. Now, how many nitrogen atoms are here? We have two. And how many oxygen? We have them as 4. What is the ratio? What is the simplest ratio? I should say, what is the ratio of the nitrogen as well as the oxygen? So the ratio is given as 2 to 4. This is what we call the molecular formula because it shows the actual number of atoms of the elements present in a compound. So this is what we call a molecular formula. And if we think of having the simplest ratio, what is the simplest ratio of this? We'll have it as 1 to 2. Now what we have here is said to be the empirical formula. So in this case, we'll have it as N or 2. Now this is a molecular formula and this is what you call the empirical formula because it shows the simplest ratio of the number of atoms present for each active element in a compound. Now let's say we have, in this case we have C, then let's say H12, actually H22 should be that. Now this is what you call the molecular formula because we have the actual number of atoms present for each element in this compound. Now what is the ratio of these atoms? We have 10 to 22. Now what is the simplest ratio for this? We have it as, that is a C, should be a C5 H11 upon having the simplest ratio which is given as 5 to 11. So this is what you call the empirical formula of this particular compound. And let's say we have another case. We have, let's say B4, let's say O10. Now what is the empirical formula for this? The empirical formula will be given as B actually 2 or 5 upon having the simplest ratio for this. And how about if we have this? Let's say we have CO2. Now what is the actually empirical formula for this? So you can see that the empirical formula will be the same as the molecular formula. So we should have it as CO2 because the actual ratio for this, we have it as 1 to 2. And what is the simplest ratio for this? It is the same as this. So we'll have it as the same. So keep that in mind. And let's say we have this. Let's say we have NO2. What is the empirical formula for this? So now the empirical formula for this is given as actually NO2 as well. So keep that in mind. And also try to have the empirical formulas. And for this, let's say we have H or 2. What is the empirical formula for this? So have it as HO. And let's say we have C6H6. And what is the empirical formula for this? So have CH. And how about, let's say, if we have C6, H12, and the O6. Now, what is the empirical formula for this? We'll have it as CH2, or in this case. So that's how you can have to evaluate the empirical formula of a compound given the molecular formula. So as you can see, let's say if we have, as you can see, let's say we have, for instance, this case, we have, let's say, the molecular formula given as B4, let's say, O10. Now the empirical formula for this will be given as B2 or 5. You see that at the end of the day, the empirical formula that we have actually, at the end of the day, this particular molecular formula is the same as giving it as this. So what it means is that, what is the simplest ratio for this? So have it as, now what is the ratio for actually it is? We have it as 4 to 2, actually 4 to 10. What is the commonly actually factor for this? We have 2 and also 2 here. And that corresponds to have it as 2 to 5. So you see that having this one, it is the same as this, where this 2 is said to be the common factor for actually 4 as well as the 10, of which if we distribute the 2, what will happen is that we'll have it as this. If we distribute the 2, we'll have it as B4 as well as the O10. That is the same as that. And what is this one? So that is said to be the empirical formula unit. And which means what you have to understand is that the molecular formula of a compound, it is the same as the empirical formula times actually the subscript n, where n is said to be that of the empirical formula unit. So in next, I'm going to look at we're going to look at how we can be able to find the empirical formula as well as the molecular formula. But this is how you should have to get it in that way. Thank you.